Hello and welcome to the third episode of the tutorial series. In this one we're going to be developing the pawn class, the board element, adding a couple abstract types to the board element class, and we're going to be adding a sort of printing mechanism to string for the chessboard, so we can actually more visually see our chessboard as we develop more and more functionality. Let's get started by going into the chessboard.java and adding our getter. This is just the way we're going to access the squares array. We need some way to access it to further continue development of the pawn class. So that's what we're going to be doing. We're going to be returning a board element, and for now we're going to be returning null if we're outside the bounds, but eventually we're going to change that to return a new empty. But that's not going to happen anyway. We know how to use and call this accessor, so we'll never run into any null problems. And then we'll return, of course, the squares at the indices, every time. So if we haven't returned null, that means we're inside the bounds, so we can just return squares at I and j. Alright, so now we're going to start working in the most important part of this chess engine, because if this part doesn't work, then really the whole thing won't work. So this abstract type is going to be called get potentially valid moves, and it's going to return an array list of valid moves. And we haven't developed valid moves too much, but it's just going to be a data type that holds and represents the movement of a piece from one position to another position. So every board element and its subtypes will have to implement a get potentially valid moves. So basically all the different ways a piece can move will populate a list. Like on the first move, when we get the potentially valid moves, a pawn has the option to move 1 spaces or 2 spaces. So the get potentially valid moves for each pawn will be a size of 2, because they could either move 1 or 2. Both are potentially valid moves. The knights in the very beginning would have a potentially valid move because they can move up past the front line of bishops. And throughout the game, the size of this list will always be different. And not all moves, just because they're potentially valid, it doesn't mean they'll be played. But we want to make sure all potentially valid moves are generated, and then we can weed through this list and determine which ones are actually valid for that turn. That being said, all of the board elements, pawn, bishop, knight, king, rook, queen, they all have different ways and different implementations of potentially valid moves, because each piece has a different behavior, a different set of rules that govern its movement. Pawns are a really complicated piece. They have, in the beginning, they can either move up 1 or move up 2. There's en passant rules, there's promotion rules. So all potentially valid moves are going to be different for every piece. And so we're going to develop the pawn first, and just the simple way. We're just going to account for the first turn of the chess game for now. So we're creating this new method, advance 1 square, and it's really going to be a helper for get potentially valid moves. Get potentially valid moves is sort of going to be like a super function for each class, because it's just going to call several helpers that govern certain behaviors of the piece. In the first line, what we want to do is figure out if we're white or black, because pawns, they can always be pushed up the board, but up the board looks different depending on if you're playing as white or black. So we're just going to see who we are, and then based on who we are, we're going to move accordingly. This ternary operation reads as if the type is equal to black, then offset equals 1, otherwise offset will be -1. Now that our pawn has a sense of directionality, if we're black, then moving a positive unit will be moving up the board, and if we're white, moving a -1 unit will be moving up the board from white's perspective. So now we can define a board element a reference to a square, we need to get a reference that is one pawn ahead of where we're at. So when we want to advance one square, we want to get our current position of the pawn, and then when we're getting the square, if we want to look up one unit ahead in the chessboard, then we can just do row plus offset. And because the row and column are where we're currently at, if we want to look up one square, then we do row plus our offset, and our offset could be a +1 or a -1, depending on if we're white or black. But before we can even finish completing this, we need to create a new class. We need to define an empty square, because if we want to advance one in the most general way, we don't want to add a potentially valid move if there's something that's non-empty in front of us. If there's like another piece in front of us, then we don't want to add another valid move to our potentially valid moves collection. Empty will be our most simple board element possible. It's just going to inherit from board element and really just have the most basic implementations of the supertype. We actually don't want to be returning null. We'll just return a new array list, because in the chessboard, when we want to collect all the potentially valid moves from all of the squares, and we want to figure out what all the potential moves could be, then we don't want to be returning null in that list. We just want to return a new array list. What other abstract methods can we easily add right now? We could probably add a get tag or some sort of get nickname, so we can just have these things, each class have a unique sort of tag, so we can easily identify it by other ways than instance of, and just an ID, some sort of value that'll be useful later. So every board element should have a different value, and that'll be helpful. So every square will have a different value, and that'll just be useful later on when we need to train the neural network. But for now, we can just implement it. You might be able to see that already with this design, it can be really cumbersome to update the superclass with abstract types, because then you need to go in and implement all the different abstract methods for each concrete type. And there's going to be a lot of concrete types that inherit from board element. That definitely you can use a different design, but this is the design that I intuitively chose. I'm definitely not advocating that this is the best design, but it definitely works. For the tag, we actually want to return a string, not void. That was my bad. Probably want to go back and fix that, but for now I'm going to pretend that we have a string to return, and I'm just going to type that if we're black, then we want to just be a minus sign, and if we're white, then we want to return a plus sign for our pawn. And you'll see why that looks nice when we end up printing out the chessboard to the console. If any of you have seen or done chess analysis with computerized chess analysis, a negative score means that black has a winning position, and a positive score means that white has a winning position. So I'm just indicating the color with a positive and negative sign, because we're not rendering images, we're just printing characters to the console. For the get empty tag, I'm just going to pick 0, but you can play around with that. Maybe you want X or some other token. Maybe the asterisk will look nice. Maybe a dash. No, not a dash, because that's a minus sign. Yeah, so you can play around with what the empty squares will look like. Pick a nice looking token. So let's hop into the constructor and just finish defining the array, so we don't have any null elements. And to make a for loop quickly in Eclipse, you can actually just type for control space and it'll auto generate, but I didn't do that. Anyway, if our current square is null, if we're not equal to null, then let's just create a new empty square, because we don't want to overwrite our defined rows of pawn. I've been trying out some new settings with this screen recording software, OBS, and I hope you don't mind that very obnoxiously sized banner for helping you remember what the parameters should be. Once that banner goes down, you can see that, okay, so if our squares are equal to null and they're not defined, let's just make an empty series of tiles defined, which is just like you would create any other board element. You pass in your initial row and column, which is I and J. You type in your board element. We're going to use our unique type empty since we're making empty squares. And then we're also going to pass in this because all of our board elements would like to read from the chessboard. Let's try and wrap up all of our functionality by making our toString method, or overriding our toString method. So what we're going to do is going to create a string builder to generate our string, and it's basically like we're printing out a two-dimensional array. Every time we're going to iterate through our array, and don't forget you can press Control Space after typing 4 to auto-generate the array. And at squares ij, we're just going to call our get tag, and then outside the second for loop, we're going to just print a new line. So that way we can get a nice matrix, since that's all a chessboard really is. We have those two for loops and a nicely sized, obnoxious banner saying that, yeah, we can type in a Boolean here if we want to, but we're not, because there's so many different overloads for append. We're just going to append our tag at the squares ij. And likewise, we're going to append system.newline, which just figures out how to do console newline carriage return in a cross-compatible way for Linux and Windows operating systems. /r/n. System.newline will get the correct one for your operating system. Not that it's really that big of a deal, but it's there. Now that we have that done, let's just connect that toString and execute it, and somehow map all this execution to our driver. So let's go to Chess Engine and create a constructor. And we're going to do that, but while we're here, let's just create a new instance of the Chess Engine that we'll call the default constructor that we're going to define in a few seconds. Oh, less than seconds, okay. So we just generated that, auto-generated that. Control Space and Enter generates a default constructor. And what are we going to put inside it? We're going to create a field chessboard, and then we're going to initialize the chessboard inside the Chess Engine constructor. And then to wrap it all together, we're going to print board. We don't even need to call toString in Java. We could just do system.out.println board. But I like to be extra explicit sometimes. And here we are. Here's our chessboard. We have all empties because we initialized all of our empties, and empty is the 0 token. We also have our plus for our row of pawns and minus for our row of pawns that are black and white, depending on plus or minus respectively. All right, well, I'm going to call it quits for this episode and for this tutorial. Covered and did a lot. So we'll work on more next time. And I'm going to upload all this to the GitHub. It's already uploaded by the time it's being viewed. And don't forget that you can access the source code on GitHub. The link is in the description. Thank you for watching, and have a nice day or night.